hopefully get my, is this right? Okay, and then, oops, that's not what I want. Sorry, Chris has been the one that's been doing most of the share content. So, here we go. Okay. Perfect. Okay, Chris says she can see the pointer and the presentation. So without further ado, again, you are here for the Trace Miscellaneous category, which is probably one of our most confusing disciplines in the lab. So hopefully by the end of the presentation today, you will have a good understanding of what this discipline is. Again, I'm Carly Spizlove. Chris Gates will be monitoring the chat, and she and I will be going back and forth as we go through this presentation. Just our disciplines that we have in Trace, as well as today, again, miscellaneous. All right, so with miscellaneous Trace, it's really a catch-all category for analysis that doesn't fit in other sections in the laboratory. So this would be questions that you guys would have for your investigative needs that could be answered through science. These can be unique particles and plastics that you find. We're also able to do analysis on glitter and cosmetics, any sort of inhalants or huffing cases. Metal analysis and suspected poisons is one we get in a lot. And then as well as last week, Chris had mentioned with physical fit that sometimes if we're not able to make an actual match, I guess, on that one, we can do analysis on the tapes or plastic bags, and we'll talk a little bit more about that as well. So these are just some of the examples of things that we can do, but we really encourage you, if you are uncertain about anything, to call the lab and talk to a Trace supervisor or one of the Trace analysts and let us know what you need, and we can kind of have a conversation about what we might be able to do to help you. So like I mentioned, there are, I didn't mention this yet, my apologies. Some of the types of cases that we frequently get for Trace Miscellaneous are things with like poison requests, such as looking for antifreeze or rat poisons, inhalants or pepper spray, the unpainted vehicle parts that Chris spoke about last week with the make, model, year searches, that falls into our miscellaneous category. And we also can do analysis on any sort of lubricant products that may be involved in a sexual assault or something of that nature. For less common requests or things that we may not have seen in the lab previously, we will try and do some research and testing with control samples to make sure that our instrumentation and analytical capabilities will help to answer your question. We will, however, reject the evidence if we cannot do testing. So we really encourage you to call the lab if you're in doubt of what we can do. Trace miscellaneous kind of falls into three general categories. The first one being of a comparison nature. So could this known sample have come from, or can they share a source with this question one? So this is very similar to when we talked about paint comparisons or glass comparisons in previous weeks. Same situation. We have an unknown sample and known sample. We're going to be able to do our analysis and provide you with either an exclusion that note these samples do not have anything in common, they are differentiated, or if they are associated, and if these questioned sample could be from this known source. Identification is reserved only for the physical fit categories as a reminder. So for the most part, your reports with comparisons are going to be an exclusion or an association. So let's kind of give some examples of what a comparison case may look like. So here we have some known glitter on an assault victim on the left side of the screen. And you have a suspect vehicle where you find some trace glitter. So in a situation where you have an assault victim and a vehicle, it may be that you encounter the assault victim first and you notice that they have glitter on their body, and you would want to take a comparison standard at that time. Or you may end up coming across the suspect vehicle first and notice that there's, again, glitter all over in the back seat or in the trunk compartment, and you may not know where this glitter came from, but if you collect a sample of it and preserve it, it may be at a later time you would come across a known source of the glitter that we could then compare them. So really think about what you're encountering and what you might be able to find later when you're collecting samples and when you're at the scene. Let's go through a couple more examples. We do not do any sort of handwriting analysis in the lab. However, if you have a note that was written with an ink pen, we can do analysis to see if the ink on the paper would be associated with any sort of pen that a suspect may have. We can also analyze metal shavings that are found in somebody's home with maybe a silencer that they had made. We can compare those shavings to the metal. The plastic bags to rolls of bags, that is again kind of going back to if we are not able to make a physical fit, but we can analyze the plastic in the roll of bags with the plastic that was maybe part of a scene and determine if they can be associated. And we also have had comparison cases involving feathers, where we were able to compare feathers that were found in a vest to feathers on a bullet. And another common type of comparison we will do is between pepper spray from one of the canisters on somebody's clothing, or the bank pack dyes on clothing compared to a sample of the actual dye pack. And similar to the plastic bags, we can also do the same thing with tape. So if we can't make a physical fit, we may be able to analyze the adhesive and parts of the tape to determine if they are associated or excluded. And Chris will now give you an example and then talk about the second category.
All right, good morning, everybody. So I just want to share two trace miscellaneous comparison cases that we worked in the last few years. This first example, as you can see, involved a piece of paper that had been torn, and there was some writing on it in handwriting with a green utensil. This was happening in a robbery, as you can see. And so what we received was this scrap of paper with the green writing, and then we also received a green colored pencil and a green Sharpie type pen, which had been submitted from searches of the suspect's home and their vehicle. So the question was, could this writing have been sourced by either one of these writing utensils, the pencil or the pen? So as Carly explained, some of these trace miscellaneous cases are similar or they're types that we see fairly often. So we work pepper spray cases multiple times a year. We've worked lubricant cases over and over, same with antifreeze cases, rat poison cases. So for those, we have an established protocol. But for other situations like this green writing, we really don't have a procedure to analyze green writing and to do comparisons. So we are simply falling back on the basics of the scientific method and utilizing the instruments and techniques that we have in the laboratory that can function to compare the chemical and physical properties of the items at hand. So in this situation, I went and used the FTIR, which is that infrared spectrophotometer, the XRF, which measures the elemental characteristics, and as well as two other techniques, paper chromatography and UV spectroscopy. Paper chromatography, you might remember if your kid has done ink paper chromatography in their elementary school science class. It's a way to draw out the different pigments in a water-soluble ink to see what they look like. So for example, a blue pen might have blue ink, but also some yellow ink or some green ink and so forth. So in this situation, the agency was requesting trace miss comparison, but also latent print processing. So we need to do the trace miscellaneous work before this piece of paper gets processed and coated with chemicals by our latent print unit. So it comes to trace first. We ended up taking some small cuttings of this item, and then the rest was preserved for the latent print analysis after the fact. And as Carly mentioned, note that this is not handwriting analysis. The state police labs no longer offer handwriting comparison. So we're looking at the chemical and physical properties of the inks and dyes in these utensils, not the handwriting itself. Oh, and I should mention, in this situation, both the pencil and the pen were excluded, so neither one of them had made the writing on this paper. This second example is probably familiar to you. We've used these photos before. So this is that example where originally it came in as a physical fit request. These pieces of linoleum, one from an illegal dump site, the other from the suspect residence, do they fit together? No, they did not. However, we can imagine that there was a huge expanse of floor. So there's lots of flooring missing here. It's no surprise that these two pieces individually don't happen to fit together. But because the items are fairly unique in appearance and construction, they contain asbestos, so they're quite old because that's been outlawed. We went ahead and did a trace miscellaneous comparison to compare the class characteristics. What is the construction? What are the elements in the yellow squares, the white squares, the tan squares? What are the different layers made up of? And that comparison then was done with the two items, the Q and the K, to see whether we could associate them and say they could share a common source. And we would do the same thing for something with regular perforations that we wouldn't expect to tear in a unique manner. So physical fit is not appropriate. We would do that with something like paper towels or plastic garbage bags or even electrical tape and sometimes duct tape where the tear is just too uniform. It doesn't have enough unique features for us to do a comparison. The second major category of trace miscellaneous cases that we receive are cases in which we're trying to classify something. So in other words, we don't have a standard to compare it to. We don't have a known. We really just have a question sample. And the question is, tell us about this sample. What can we figure out about it? So the bullet points here just show some examples that we work. We might look for a hit and run victim and see, is there any vehicle paint on this person? We've also done similar work if there is a recovered body out in the woods. What is on the body? What types of trace evidence are here that might be useful? Are there fibers? Are there wood chips? Are there specks of glitter? You know, what is here and what can we categorize it as that might be useful later on? For glass, we might try to figure out what type of glass it is. Is it smartphone glass versus container versus vehicle or building window? And then, of course, if you are working any cases involving arson, all arson analysis, which falls under its own category, is a classification analysis. We are looking for traces of ignitable liquids and then classifying them as what type of ignitable fluid they might be. And then Carly gave an example earlier about metals. Metals are a separate category where we look at the elements that are present, and we can give you information about levels of metals or types of construction, layers of metals that might be in a particular item. So for classification, we are using, again, our instruments and our microscopes, and we are measuring certain features or characteristics about these unknown items. And then we're using either lab reference samples or our training or sometimes databases to figure out what do these characteristics lead us to think that the category or classification should be of this item. And I'm going to pass it on to Carly to tell us about one of her recent cases.
Right. I had a very interesting classification type case. It had been that an individual was pawning some gold necklaces to separate pawn shops around town. And the question was, do the necklaces contain gold? The pawn shop had paid out the individual as if this was 14 karat gold, as the necklaces were stamped. And then it was kind of after the fact, they had, one of the pawn shops had one of the necklaces melted down while the second one was still intact. So I was able to analyze both the melted chunk that's this top photo here, as well as this gold chain that was also submitted. The agency was fine with us doing any sort of cutting that we needed to do. So I was able to do both analysis on the outside of the necklaces, as well as I cut it so that we could do metal, or we could do analysis on the inside. Through my testing, I was able to determine that there was a lot of copper, a lot of zinc, a little bit of silver, and a really minor amount of gold. There was, when I had analyzed the outside of this necklace, I did detect gold, but on the inside of it, there was no gold. So my report went out with an opinion that these were actually gold plated rather than gold filled necklaces. All right, the third general category that we usually see in miscellaneous is of a detection or identification of chemicals. Most of the time, these are going to involve kind of some sort of poisoning or tampering of items. So for instance, is somebody has some shampoo and they suspect there to be acetone, we will analyze shampoo looking for that, or any sort of animal abuse cases where maybe you have some disagreement between neighbors over a barking dog. There are some hot dogs that were found. The question is there rat poison in them? Chris worked a case that involved the question of, is there concrete in this milkshake, which was definitely an interesting one for us, as well as any sort of baby formula that's been tampered with, for instance, antifreeze. Any sort of case that we're doing where we're looking for a specific chemical, it really helps if the agency has an idea of what they suspect to be in the item. And we ask that the agency submit a positive control sample. And the reason is if we don't have any sort of procedures in the lab, then that way we can work with the control sample to really make sure that our instrumentation and analysis can detect it, and we're not actually using up all of the evidence sample. Once we actually have identified something, we are able to use reference libraries. However, our preference is to then kind of compare it back to that control sample that was provided. It just gives us better agreement between data when the samples are run on our instrumentation versus an external library source. I basically just stated that we do require the positive control. Also, there may be times when a negative control would be useful as well, and we will, I think the next slide might have an example of that. Yes. So a tampering case might be that a student thinks their roommate is tampering her top ramen, and they suspect that it's being laced with some laxative powder. So in an example like this, or in a situation like this, we really request 3 evidence samples. The first being the remains of any uneaten ramen sample. The second is that suspected laxative that was used. So we can, again, look and use our instrumentation on the control sample to make sure we can see it. And then finally, we ask that if you can, to provide a negative control. So in this situation, an unopened container of the ramen. And Chris will explain, I think, why it's really important for us to have negative controls.
I'm turning it over to Chris. We're getting our steps in today, switching back and forth. Yeah, so as Carly just mentioned, a lot of those type 3 detection cases that we do get in, there is a known target, like the laxative in this example, and that makes the work fairly straightforward to us because we can just test the sample of ramen that you submitted that was left over from the person who was eating it, and we can figure out, well, is there laxative in there or is there not laxative in there? We have seen laxative tampering at least twice in my memory, so it does happen for sure. But the other type of detection cases that we get are more difficult for us, and these are the cases where there is not a known target. So the evidence basically comes in with the request to screen for poisons, and there's no indication either from the person's symptoms or the case scenario or the scene what the poison might have been that is used. So obviously, there are thousands and thousands of toxic chemicals out there in our environment, and some things are perfectly fine in certain doses and then toxic in higher doses. So when we get a case like this, what we will do is do a general screen, and this is what that general screen will detect. It will detect most controlled substances, excepting some date rape drugs like GHB and butanediol, that sort of thing, unless the incident report that we receive from the agency indicates that that might be merited to include that in the screen. So these unknown screens will catch controlled substances, and then they'll catch obvious toxins such as heavy metal and strychnine. But it's going to miss a whole bunch of other things that could potentially be in this item that are toxic, including most pesticides. We simply don't have the resources or the instrumentation to design protocols to detect every single compound that may be toxic. So we usually get these cases when someone contacts law enforcement and they think they're being poisoned and they really don't have any concrete evidence about it. And we get that. We get that sometimes you want to do your due diligence and submit this item for testing to the laboratory in order to make that citizen feel as though they are being taken seriously and that their concerns are being addressed. So we don't want to discourage you from submitting those if you think it is important to do. But please know that the screen that we do, if we don't have a target from you, is going to be general, and it would miss a lot of things that could be used as poisoning agents. What we will do is read your police report very carefully. This will steer our analysis. And what helps us is to look at relevant timelines and any symptoms, or perhaps the individual reports a strange taste or a strange smell or a sediment, any kind of details or clues that would help us know, was this a fast-acting poison? Did it induce vomiting, or did they become lightheaded? Did they pass out? That all helps us. So please do include that in the report that you submit with the evidence. Most of the time, the results that we get in these no target cases are negative. So just putting that out there. So this slide, I think, is a great example of why we ask you to submit those controls, both positive and negative. So this spectrum probably doesn't mean much to you just looking at it. So let me talk you through it to show you how we see it from the lab point of view. So this is a case we received a few years ago where a person at a bar suspected someone behind the counter of poisoning their drink with Windex. So the drink itself was primarily one of those pomegranate juice beverages, and the Windex is the target. That's the sample poison that the agency thinks is involved. So the agency submitted the remains of the suspected tampered beverage, and then we also got a positive control, which was the bottle of Windex, and a negative control is just a normal POM beverage that was unopened and hasn't been tampered with. So that was pretty easy to get our hands on. I believe we obtained that ourselves. Sometimes we'll ask you to bring it in, definitely. But if it's something pretty simple, we might be able to get it ourselves with our petty cash. So in this situation, the scientist needs to know, well, what is in POM beverage just by itself? And then what is in Windex? What are the components of Windex that I might be able to detect in the beverage? So there are two lines of data here. One is black and one is blue. And the black one is the POM control. So this is the negative control. And you can see there's a lot of lines here. Each of these lines is a separate compound or chemical in the beverage. So for every peak that you see, that is some chemical in this beverage, because of course all physical objects are made up of chemicals. And then the sample, the beverage that was tampered with, that was submitted, that's the blue line. And if you look at them, all the peaks kind of mirror each other, right? So the peaks are very similar, even tiny little blips like this. They're in both the POM that was not tampered with and the POM that was suspected of being tampered with. So they all line up, except this peak right here. So what this does for us in the lab is it makes us zoom in on the differences, right? Because we would have to spend hours looking and investigating every single chemical. Is this a poison? Is this a poison? Is this a poison? Could this be a poison? If they had enough of it, that takes forever. But when we have these two rows of data to compare, now we can check out this peak by itself, because this is something that's in the tampered beverage, but not in the control. And what did this turn out to be? That peak, which was at 7.3 minutes on the printout, is a chemical called 2-hexoxyethanol. Let me say that again, 2-hexoxyethanol. And when the Windex control, the positive control, was run by itself, one of its main components was this same chemical. So that is such a shortcut for us. It makes our analysis in the lab so much more meaningful and efficient, because now we can say, yes, in this POM beverage from the victim, there was this chemical which was also seen in the Windex, and we don't have to spend all the hours to investigate every possible other chemical that is just naturally in this juice. So when a sample from your investigation comes into the lab, we evaluate it at the front desk and we decide what type of analysis is needed so that we can send it to the right section or unit of the laboratory. So let me just put the caveat up there at top that we will not test feces and we will not test hair for poisons. There are external labs that can do both of those things. So if you have a case where that is crucial, we can give you their contact information, and it's a fee for service type of system where the sample is sent out to them. What we will do is, if the suspected poison that you know you're targeting is a controlled substance in pre-ingested form, we will send it to the drug chemistry unit, because pre-ingested controlled substances, that's just drug testing. So for example, if you think a brownie has fentanyl in it, or if you think some homemade candy has THC in it, those sorts of things would go to our drug chemistry section. Pre-ingested, so it has not entered the body yet. On the other hand, if the poison has been ingested and it's now contained in some sample, which is a body fluid, and that could be urine, blood, breast milk, vomit, or stomach contents, lucky them, that goes to toxicology. And the reason it goes to toxicology is that their techniques and their instruments are best suited for detecting the low levels of these compounds that you would find in any of these body fluids. Because if by that time it's been potentially metabolized and changed into other compounds, and their techniques are extremely sensitive because they always work with body fluids. And then trace miscellaneous gets everything else. So if it's not a controlled substance in pre-ingested form, or if it's not a body fluid, then it comes to trace miscellaneous. And just a reminder that we would get baby formula, because it's not a body fluid is just considered like a beverage. So here's an example of a missed opportunity for trace miscellaneous that kind of sent us in the lab on kind of a goose chase. So the situation was there was a suspicious death of a female in her own apartment, and near the body, as seen in the scene photos, there was a cup of liquid. There was still liquid in it, but the liquid was not collected. Instead, what the lab received at first were tox samples from the autopsy. So they're going to get blood samples, urine samples, maybe some tissue or organ samples. And those were screened using their normal techniques, and they all came up for negative for controlled substances or any obvious toxins. So because they had hit kind of a dead end at that point, they sent samples to an outside lab like the one I was just mentioning. And the outside lab detected ethylene glycol, which is the main component in most antifreezes. Now, ethylene glycol is not part of the normal tox protocols. They would normally not find it, just like sometimes trace doesn't find things there because our protocols don't search for them. So once we knew that, the scene photos were given a second look, and it was noticed that in the woman's bathroom, there was an empty, well, we couldn't tell it was empty from the photos, but there was an antifreeze container in the bathroom trash. So that does seem kind of weird because how many people have their antifreeze in their bathroom? It just didn't really make sense. And so what would have streamlined this case as far as a lab testing perspective was to sample the liquid in the cup near the body and send that in as well as the tox samples. That sample would have come to trace miscellaneous. We can detect antifreeze fairly easily. We have a procedure for it. We have an instrument that's well suited for it. And now once we know that, we can give guidance to the toxicologist to say, hey, we found this. You might include it in your screening techniques and see if you can detect it as well. It's always easier to test drugs and poisons outside of the body before they go into the body because of all that metabolization that happens. So collect anything that might have been ingested, collect what remains, and you can also collect paraphernalia. Even the empty cup could have useful residue, or clearly if there's a syringe or something else that indicates that someone may have utilized some toxin before their death. So here's just kind of a more extensive list of some of these miscellaneous trace case examples. Some of them we've mentioned already, like the inhalants. And then we have tested unknown liquids that have been used in vandalism or assault cases or in suspicious deaths. We've tested acids and paint strippers that were thrown at people. We've tested suspicious deaths where it seemed that the person was drinking drain cleaner. Still, I think unclear whether they drank it on purpose or whether it was accidental. We've also tested liquids associated with suspicious deaths that turned out to be fatal nicotine overdose, likely intentional. And then sometimes we get a sample in and we test it, but it just turns out to be water, sometimes dirty water. But that's fine. We've exhausted all our testing and provide that information to you. Trace miscellaneous could also include samples that are collected from arson scenes, but which need testing for things other than ignitable fluids. So an example of that would be if a flare was used as an ignition source or some other fuel source, we can test the remains to try to give information to the investigator about how that fire may have begun. And then, like Carly mentioned already, we will do work on personal lubricants. We could screen garments such as underwear or sex toys, all that sort of thing is a comparison that we can do. All right, so what will our lab reports say? It isn't on this slide, but of course you should know by now that all of our reports in trace analysis will include the methods and tests that we used. That is an accreditation requirement for us. So if the trace miscellaneous case was a type 1, which you remember was a comparison of Q and K, the report will either tell you that there are measurable differences between the Q and K, and that's an exclusion, or it will tell us that we cannot differentiate the Q and the K through any of our testing, and the report will say that the known item or another similar item with all the same properties could be the source of that question sample, and that is an association, and you may see us start to use an association scale. However, I mentioned last week that with these miscellaneous cases, because sometimes the evidence is more unusual, we as experts have less information about the population of that sample type. And so it may be more difficult for us to assess the significance of that association. But we're going to be somewhere kind of in these three main categories. Either we have something that is very unusual, and so association would be a stronger support for the idea that they originated from the same source, or it could be something that is only moderately strong or strong support because, yeah, they are indistinguishable, but we're not really sure how many of these same types of items are out there in the world. So we kind of put it in the middle category. Or then the lowest category, which would be association with limitations, is yes, we can't tell any difference here, but it seems like it's a very common type of item. So plastic bags would be something that would probably fall in this category. Yes, these two plastic bags, one from the crime scene and one from the suspect's garage, are identical in every characteristic that we tested, but how many other plastic bags are out there that are just exactly the same? Probably a pretty large number. So that would fall in this kind of lower category. Trace reports that are in the second type and the third type, either the classification or the detection. Again, we will describe the instrumentation that we use and our findings. And you will see on the reports whether we identified a probative chemical. Again, we're not going to list every chemical we detected because everything's made up of hundreds of chemicals pretty much. But if there's anything probative, so is there anything that could have been poisonous or toxic, that's related to the request. And sometimes you'll see us kind of use a little more wiggly room because we have testing results that indicate something is there, but perhaps we don't have a good standard or control to compare it to, and the library reference is just not up to our standards. So we might put some wiggly wording about that testing indicated that it was there, but it was not confirmed. And that usually means that we have some pretty good results that lead us in that direction, but it just didn't reach a threshold for us to say, yes, 100%, I know that's what it is. We will also report whether the standards or controls submitted were inadequate for full comparison, or if the testing is limited by other factors, such as the passing of time. And for a lot of trace miscellaneous cases, especially for chemicals like bank dye or pepper spray or lubricants, the passage of time is important because the samples will evaporate or degrade. So the sooner you can get them into us, the better. If we have a negative result, like the one for this example, here's what the report wording will resemble. So in this case, we have a poison screen. It was one of those general, hey, I drank this poison, or excuse me, I'm taking that back. I drank this coffee, then I got sick, so I think there was poison in my coffee, test it. So we don't have a target. We have no controls really provided for what that poison might be because it's just a guessing game. So the report might describe that we tested this exhibit using these types of instruments. And we also ran some controls. So in this case, this was the case of mine. I just made some coffee and added some creamer and things to kind of make it resemble my best guess as to what the sample started as. It definitely had coffee in it. That was given information, and then it was described as a latte. So I'm assuming there's dairy. I could be wrong. And then I run those as my controls to try to do that comparison of what is in this sample normally, and is there anything different in this tampered beverage. And then the report, if it's a negative, will indicate that there is no difference between these control samples and the sample that was submitted from the police agency, and that no drugs or toxins were detected via these methods. And then this last sentence in italics is one that is a message to you. We're sending this kind of back to you and putting it back on your plate, and telling you, if you do, through your investigation, develop a toxic agent, so now you have a target. If you figure out what that might be, then go ahead and contact the lab to pursue further testing. Because once we know what we're looking for, we might be able to develop some additional tests that can actually say whether it is there or not, versus this general screen that was performed at this level. If you do see a trace miscellaneous report with negative results, this could be due to our instrumentation limitations. They're only so sensitive, although they are really, really sensitive. But the compound could be present just below our detection limits. Also, two things that we associate may have subtle differences that we couldn't detect, so that's always a possibility. And then when two samples are associated, we often have little expertise in some of the frequencies or rarities of that type of sample. And that's in contrast to the glass and the paint samples that we see all the time. And so we're much more comfortable there assessing whether something is common or not. Next, Carly is going to start explaining about packaging of trace miscellaneous.
All right, for any sort of sample that is a food or beverage in nature, we really would love it if you would refrigerate or freeze that at your property rooms, and then we will continue and have that refrigerated once it comes into the lab. And expediting testing and getting it into the lab to be worked sooner rather than later is really helpful. As Chris had mentioned, samples degrade, and as they break down, it can be much harder for our analysis. Chris kind of did touch on the fact that pepper sprays and inhalants can be volatile. So if there's anything that's really been designed to like hell at you, odds are there is a chemical in there that's meant to evaporate over time. So with anything that is volatile, we ask that you don't use paper packaging because the compound will escape. So we really would love for those to be packaged and preserved in something such as a glass jar, a plastic bag, a metal can would work as well. And again, the sooner you can get them into the lab and submitted, the better. The final note on here is really important, and that is the more sample that you can provide us, the better our analysis can be. We really would love for you to collect as much liquid as, so if you have a cup of liquid, collect all of the liquid rather than just a small sampling. If you have powders, again, try and collect as much of it rather than swabbing it. Since there are times when we need to kind of adjust our analytical process based on the evidence. If we just have a really small amount to work with, it may not be enough to really do a full analysis and to give you any sort of meaningful results. So the more sample, the better. For anything that's liquid, we really would like it to be in some sort of contained jar, or those urine specimen cups work really great to prevent any sort of spillage. And then put that in some sort of durable outer layer, such as like a cardboard box. We would caution you to be very careful with anything that's a suspected acid or caustic solution, and include some absorbent material, because if those do spill, they're not not good to have on people's hands. For anything solid, your usual like plastic bags are fine, or even again jars or little canisters. And with all the trace, we really ask that you kind of have that 2-layer system. So to put anything into another layer, and just kind of a reminder that with anything solid or powdery, to be really aware of the packaging you're putting it in. So if you're putting it in an envelope, that was hard to say, or a paper bag where there are any little crevices that the evidence can escape through, might not be the best packaging choice for that item. On the Form 49, there's 2 requests for like the fill-in type digital copies, and that's usually the other/trace miscellaneous request type, and that's going to be pretty much for most things except poison. So if it is where we're looking for a specific toxin, that would go under a poison analysis. And again, Chris had walked through if it's pre-ingested, then that in a controlled substance, that would go to our drug chemistry section. If you're dealing with any sort of biological liquid, that would go to our tox section. And really, if you're ever in doubt, you're very nice and you can call us and we will help you. With most trace evidence, again, like the double layer system is really great for us. We really want to make sure that all of those little teeny objects sampling is not going to get lost. So jars, specimen cups, whatever you have, we really would love it if you put it in some sort of larger outer packaging. Again, a reminder, do not use paper bags for anything volatile, but plastic bags and manila envelope or boxes are great for other things like liquids, powders, and whatnot. The more information you can give us about the samples, the better. If this is through an incident report, that's great. Or, I mean, even just putting where things were collected and as much evidence or as much information on the evidence as possible is really helpful for us. We can do a more thorough analysis with the information. So how long does miscellaneous analysis take? That is a really open-ended question. Currently, there are 5 analysts in the state who do this type of analysis. And as we've explained, there's all sorts of different types of analysis that we can do. So if we're dealing with something kind of routine, it may take us only 8 hours to work the case from start to finish. But in some of these cases where we don't know exactly what we're dealing with, or it's something we've never had in the lab, and we're having to use those controls to find methods to see if we can even analyze your evidence, it might take upwards of 40 hours or even longer. And the time will be delayed if we don't get proper reports about how things were collected, or if we need a positive or negative control and that has not been provided. So, I mean, honestly, the turnaround time is really, really dependent. However, like most things in the laboratory, it really is going to depend on the crime level. We do prioritize people crimes and things that are of a safety concern. For testimony purposes, we can explain our analytical procedures. So any of the instrumentation or analysis that we did, we can explain what we did and why those instruments or analytical techniques are accepted in the field for forensic analysis or comparison. We can also explain what our findings mean in a little more detail and kind of any limitations that may be surrounding that. So Chris had kind of mentioned sometimes with plastic bags, it might be kind of a limitation, or excuse me, an association of limited characteristics. Thank you. And we would be able to explain those during testimony. We also can offer any sort of expert opinion about maybe something that is significant. So if there is some really highly distinguishing characteristics, we can kind of, again, explain those while we're testifying. And as always, we can talk about our lab accreditation status and all of the quality assurance protocols that we do to ensure that our analysis is done correctly and of the highest standards. While there is a whole lot of things we can do in trace miscellaneous, there is also a list of things, or there's also a lot of things that we cannot do. And I won't go through all of these. You should all have a copy of these slides. But just to kind of hit some things, Chris had mentioned we don't do any sort of fecal matter testing. We cannot do any type of pollen analysis or wood determinations. And then some things we just kind of do on a limited basis, but it may be performed by another section, such as the gunshot residue screening. Firearms can do that on a limited basis. One thing that I will kind of note that we do get a request for a lot are tire or rubber substance comparisons. And we cannot, unfortunately, do any sort of analysis with rubber at this time. However, that does exclude any sort of tread marks that would still go to impressions. And we do limited stuff with pesticides and herbicides. Again, we have some standards in the laboratory. We've done some analysis with it, but again, we can't screen for everything. It's always better if you have that target compound like Chris mentioned. And again, just to kind of hit it, if you are looking for any of these kind of specialized examinations, talk to a trace technical leader. They can kind of point you in a direction of a laboratory that would be able to help you out if that is important to your investigation. And with that, I will ask if anybody has any general questions about trace miscellaneous. Okay, nothing in the chat. I think we're doing good on time. So I know Chris is going to give you a good case example that kind of will show how trace miscellaneous can be used with other sections of the laboratory. And since this is kind of the conclusion of our webinar series, I just kind of want to put out there that if you do have any lingering questions from our glass, paint, physical fit, or make, model, year searches that we haven't answered, this would be a really great time for you to put those questions in the chat, and we will get to them at the end. Or if you have any kind of questions about, hey, I'm working this case right now, and I am interested in looking for X compound, can you do that? You can put that in the chat as well. But right now I'm going to turn it over to Chris one last time, and she will walk you through a really fun example.
Yes, we're not trying to be kind of insensitive and cruel. This is a fun example where somebody died, but you know, that's what we deal with, and I know all of you do as well. So what's fun for us is the science aspect of it, for sure, and the fact that we can help justice. All right. Okay, so now that we've kind of gone through the separate areas that we've talked about over the last 3 weeks, I thought this one would be a good case example to show the different types of trace analysis coming together, but also how other units in the laboratory, DNA, latent prints, and so forth, also worked on this case. And we all kind of worked as a team in order to get to our final reports. And actually, this one didn't go to trial. I think there was a plea agreement. So the scenario is we have a bicyclist fatality on a rural road, and the victim at autopsy was the source of multiple collections of evidence. So her clothing and shoes and bicycle helmet were all collected, as well as standards of her hair, her DNA, and her deceased prints. And then from the scene where her bicycle and body were found, the collection was of the broken vehicle parts that were left at the scene, ostensibly by whoever hit her, and then her mangled bicycle, which you can see below. So here's her helmet, here's her mangled bike frame, and then this is a close-up of a portion of it that turned out to be important later on, and this is one of the plastic vehicle parts collected from the scene itself. So later on, actually fairly quickly, a suspect was developed because a neighbor observed after hearing of the local fatality that there was damage on this suspect's vehicle in the passenger right front area, which would be the side of the vehicle that would potentially, come into contact with a bicyclist who's on the side of the road or in a bike lane. The vehicle didn't have any broken windows or the windshield, but the front light assembly was shattered. So remember, most vehicles nowadays, those light assemblies are plastic rather than glass. So we have a damaged vehicle with broken plastic and missing paint. When interviewed, the suspect said that he did hit something. He hit a deer. He ran over it, but that he didn't get a good look because of the sun kind of shining in his eyes. And so this alibi poses some interesting questions for the laboratory analysis. So what we were trying to do was assess the evidence that we were given to answer two questions at the onset. One, was the damage on the vehicle caused by striking a deer or a bicyclist, or potentially both? There could have been two separate strikes. And two, can we determine whether the impact through the body, whether it's a bicyclist or a deer, over or under the vehicle? So we're kind of assessing the physical evidence, and we're also assessing the truthfulness of the alibi. So when we're talking about alibis and information provided to the laboratory, this is a great time for me to emphasize that we ask you to be selective about the information that you give us. So in this example, we do need to know that his alibi is that he struck a deer, because we want to evaluate, okay, are these blood samples or hairs on the vehicle consistent with human, or are they consistent with animal? So that's a part of the alibi that we need to know. But we do not need extraneous information about the driver's history of UIIs, or the bicyclist's beloved community standing, or how much the community is rallying behind this situation, or any other factors that do not directly impact our lab analysis in the case. And the reason we ask you to refrain from telling us that information is we don't want any chance of becoming biased, or that there's a perception of bias from us knowing this information. We need to know crucial information about the samples, where you collected them, what do you think they are, why do you think this is poison, and all that stuff. But we don't need to know the next layer of information about, oh, you think this guy is really bad, or you think she's not telling the truth, or so forth. Leave that out of it for us. And if that means you have to redact some of your report, please, we ask you to make that effort. So back to the case, here is the close-up photo of the damaged portion of the suspect vehicle. You can see it is a vehicle with a black paint job, and here's the broken plastic. So there's part of this light assembly still on the vehicle, but in the interior it has been shattered, and many parts have actually fallen loose and have been lost to the ground along the way as the vehicle was moving. And then you can also see that there has been a fracture of this grille material, which on some vehicles is still metal, but most vehicles now have made this a plastic item. And instead of it being actual chrome or steeled chrome, or chrome steel, it's usually now plastic with some kind of chrome colored decal, which is what it was in this circumstance. So what evidence was transferred to the scene? Well, we can see there's some missing paint. We talked about how paint has a tendency to pop off of a metal surface as that metal is deformed or bent through the force of the impact. And then there's some plastic pieces missing as well, and that's true for both the light assembly and the grille. Now, could a vehicle have missing paint pre-existing an event? Obviously, yes. But remember that paint acts as a protective coating for metal body panels. So if your vehicle is missing paint, it's not very long before the elements start acting on that exposed metal and we start seeing rust appearing. And so the fact that there's no rust where this paint is missing makes us likely to think that this is a fairly recent event. And of course, the season of the incident would have an effect on that, as well as the climate. Here's just another view of that missing paint. You can maybe see that there's even some really loosely held flakes or strips of paint here in this area. So the paint is kind of loosely held by one edge, and then it's not in contact with the metal of the vehicle anymore. So again, a good tip off that this is not a pre-existing location of damage, because those pieces would quickly blow off, with high-speed vehicle movement if time was elapsing. So now that the suspect vehicle has been seized and there's a search warrant, a whole nother list of evidence was collected. You remember there was a bunch of evidence collected from the autopsy and the scene. Now we have additionally these items collected from the vehicle. We have paint standards in the areas of damage. We also have some areas on the hood that look like they've been abraded or something has been rubbed off onto the hood. And that kind of travels from the front of the vehicle all the way up to where the windshield begins. Again, we don't know if this is pre-existing or if it's associated with the event, but we'll test it. We also get the disassembled broken light assembly. And then possible hairs and fibers were collected from the hood. Swabs of possible biological material, including blood, was taken from the damaged quarter area. And then some latent prints were collected from the hood as well. But as you know, we often triage evidence and we don't allow you to send it all in all at once. So what came in at first was just two items: a single set of blood swabs, blood in parentheses or quotations because it hadn't been proven to be blood at that point. It's just presumptive blood, and then a sample of this transferred smear from the hood. So those were worked initially, and the result for the swabs was that there was no human blood. And that's not really surprising, right? This is a rural area, all sorts of vehicles in all areas, urban and rural, probably have animal blood on them. I know I probably do from that kamikaze squirrel that ran in front of my car. So, you take enough swabs from a car, you're going to find blood, but not necessarily, for most of us, at least, human blood. So the processing of the vehicle, it looked like there was blood there, but it turned out not to be human blood. So is it deer blood? We don't know. We don't do that testing, but it's not human. And then the smear turned out to be polycarbonate, and this was compared to the plastic of the victim's helmet, which also was polycarbonate. However, when we talk about this comparison, this is kind of a trace miscellaneous comparison of one plastic type to another. They are the same type of plastic. However, as you probably know, polycarbonate is a huge class of plastic manufactured items. So you could have a cooler, you could have a water bottle, you could have all sorts of things that are polycarbonate in addition to this helmet. So it's a classification that they're the same plastic, but it doesn't really narrow it down very much to us having good, solid support for this polycarbonate smear being from this item, the helmet. So that's when we as lab staff would work again with the investigating agency and try to figure out, okay, what needs to come in next? We didn't answer the questions with our first set of evidence. So what can we analyze next in our kind of flow chart? So we ended up, I think if I remember correctly, there was a trial date that was pending. So we ended up just saying, submit everything else you've got so that all the sections of the lab can be working on it simultaneously instead of having to wait for one section to get done before further evidence was sent. So we got the latent lifts and the standards from the autopsy. We got the paint standards from the vehicle. We got more smears from different parts of the car or truck. Those hairs and fibers that were seen on the vehicle, more swabs of possible blood, and then the victim's clothing, her bicycle frame, and the broken plastic at the scene, as well as the broken light assembly taken from the vehicle. Whew, that's a lot. That'll keep us very busy. So the first thing that we looked at in the trace section was, here is that light assembly that has been disassembled, and all the broken pieces that were still present on the vehicle were submitted in a big paper bag. So you can see there's some reflective pieces, clear, orange, black plastic, and so forth. And then this is the piece that was found at the scene. So we're looking to see, is there a physical fit between this scene piece and any of the pieces from the vehicle? And yes, indeed, there was a physical fit. This was designated Exhibit 23. You can see it here, and it fits up with one of the pieces here. I can't remember which one. However, the guy says he hit a deer, right? So this physical fit, although awesome and puts the vehicle at the scene, it doesn't answer the question of, did he strike the bicyclist? Because this, the presence of this broken piece could be explained by a deer strike. So we keep going. So the next step for the trace section was, we screened the victim's clothing, helmet, and shoes for paint transfer. So again, I'm looking for black vehicle paint from the truck transferring to clothing, helmet, or shoes. Unfortunately, none was observed. Then the bike itself was screened for paint transfer from the truck. There was a lot of black material on the bike frame. You can see some here in this close-up, but unfortunately, none of it turned out to be paint. It's more consistent with tire rubber, and some of it was probably tire rubber from the bike's own tires, just the way that the bike deformed under impact. The back wheel was kind of bent and deformed up against the frame. But again, we don't really do tire rubber comparison, so I had to stop there. But we can certainly say it was not paint from the truck. So then we looked at the samples that were taken from the truck itself to compare with the paint that was on the bicycle, because most bicycles are painted. They have a very interesting type of paint on them. And so I'm looking at these samples collected from the truck to see, can I find any bicycle paint on the truck? And with that analysis, we were able to find bicycle paint on two separate areas of transfer that were taken from the truck. So we made an association which established likely contact between the vehicle and the bicycle. So at that point, the physical match doesn't really answer the question, because it could be explained by the deer strike, but this paint transfer cannot be explained by the deer strike at all. And so we have made contact between the suspect vehicle and the bike itself. So that was the trace part of the game. Then other sections are continuing to work as well. And DNA later also established that they found victim DNA on swabs from the truck, its bumper and its grill. So now we have both biological evidence and physical evidence that tie this truck to the victim and her bicycle. So they're working in tandem, and you can't try to explain away the DNA by saying, oh, you know, that person probably spit on my truck 2 weeks ago, you know, or that person was in my neighborhood and I'm sure they leaned against my truck. No, we have established the DNA and the contact with the paint, and so they work together. The fibers turned out not to be fibers. I believe they were like plant seed fibers, not like clothing fibers. The hairs turned out to be hair fragments, which were not suitable for any further work, and the latent prints were inconclusive. So, you know, I love this example because when the evidence is first collected, there's really no way to predict what is going to pan out. We did a bunch of analysis that was a dead end. You know, the physical match was a dead end. The fiber work, the hair work, the latent print work, those first set of blood swabs, all dead ends. But because so much excellent evidence was collected initially, both from the autopsy and the scene, as well as later when the victim, or excuse me, when the vehicle was seized, all that evidence did eventually establish a route to answering these questions. Now, if we could do that 100% of the time, that would be amazing. I don't want to make any false promises. We certainly cannot do it 100% of the time, but we will never do it if the evidence isn't collected by you in the first place. So that's what we would definitely like to encourage you to do. So as we wrap up, just a few more reminders about all the types of physical evidence that we have talked about in this series. The evidence that we're focusing on in TRACE is typically physical evidence such as glass, paint, or fibers or other materials or chemicals that cannot individualize a source with the exception of physical fit. It can't individualize a source to the exclusion of all others, but it can establish a link between a person or object in question and an event or a scene. And in some of these events, biological evidence is not transferred or may not be probative. So think of both sides of your evidentiary coin, the physical side and the biological side. And I just mentioned this a moment ago, our lab work is only as good as the evidence collected by you. So please be proactive and collect those standards, even when you don't know that they will be needed down the road, or collect question items. Ooh, that should say question items, not question glass, even if you don't have a standard yet. And then think about how can you build your case? Are there multiple ways that we can show an association? Is there biological evidence, but also glass? Is there paint, but also glass? Maybe some fibers. The more links we make, the less likely it is that a jury can write it off as just a coincidence or a random association or match. And you've seen this slide before, just some contact information for you if you have any of those questions. Carly, are there any questions in the chat?
How would you present the bike to the lab?
Oh.
The bike brown paper, or would a box be better?
The question in the chat is how would we get that bike in the lab? Is brown paper wrapping okay, or is a box better? In this case, the frame was missing both of the wheels, and so it was pretty easy to find a nice box that it would fit in. However, if you do have any item, a bike or something larger that you cannot get a box for, yes, brown paper will work as long as it's sealed completely so that nothing's going to fall in or out, and that you might need to pad sharp parts like the end of the handlebars or part of a pedal. You might need to pad them with bubble wrap or something so they don't pierce your paper wrapping. In some extreme cases, if you're only interested in one small area of that object, you can just mask that off, protect it, and just package that area without packaging the whole item. However, in this circumstance, we were screening the entire bike frame, so we needed to have the whole thing protected. I am going to spotlight myself just to finish up. Are there any more questions, Carly?
If you have something that has biological and a volatile substance, what would be the best way to practice it?
Yeah, that's a good one because we do see that, right? We'll see a shirt that has both blood and potential pepper spray or something like that. So first of all, get it to the lab quickly, because if you do end up putting it in paper because you need the blood evidence not to mold or decay, then the sooner we can get it up to trace and repackage it into plastic, the better. I would say ask yourself which evidence is more probative to your case. So if the scenario is that the victim has potential pepper spray from an assailant, and they also had their nose punched and they're bleeding, that may be their own blood on their shirt. And so if that's kind of where you're thinking the case stands, you're not really that interested that blood is tested, but you're more interested in the pepper spray. So make the choice of packaging to preserve the pepper spray versus the other way around. You think, oh my gosh, this is probably the suspect's blood on this shirt. This is going to tell us who the assailant is, and the pepper spray is of lesser importance. Then package in paper to preserve that blood evidence best, but get it to us fast. Write on your paperwork that you're interested in both testing, and we will cooperate in the laboratory to do what we can to preserve it once it gets here. I hope that helps answer that question. Okay. All right, so I'm going to just have a few closing housekeeping items for you in our last moments. One, I just want to really thank everyone for dedicating your time. I know this is a lot of material to just be blasted at you, and we're such nerds and we can just talk about it forever, but we appreciate our audience. I do have to say, this has got to be the most awkward public speaking venue I think I've ever done. I can't see your faces and I hate it, but it's been nice to know that you have stuck with us for the 4 weeks. Attendance has been really good, and we hope that it has been helpful to you. You will be receiving a link for a survey. I think there's 7 questions on it, so it shouldn't take you too much time. The reason we're asking for everyone to fill out the survey, whether you loved it or hated it, is our management is trying to decide whether we as a lab system will allocate future resources to putting more of these together. So that helps them make a decision. And then for us as the Trace folks, we're interested in knowing, you know, which of these did you find more useful and how might it affect your investigations in the future, now that you know a little bit more about what we can do. So expect that survey before the end of the workday, my workday today. There is also a question on the survey about which topics would you be interested in for future webinars if we decide that we're going to go forward with more of these. That will help us prioritize so that we can target the areas that are of most interest and value to you. And then remember also that we have been recording all of these presentations. And once we get the IT work finished and we have links available, you'll get an email with the location where they can be viewed. And I'm not sure of the timeline. I'm kind of at the mercy of some other folks to do that portion of it, but look for a communication from me, hopefully in the next month with those link locations. So if there's nothing else, no further questions? No. All right, Carly and I send our thanks once again. We look forward to seeing your wonderful trace evidence submissions in the coming months. And I hope you enjoy this beautiful Oregon spring day. Signing off. Bye, everybody.